video too?
I'm going to check that we are live. So this is for people who are watching this. This is going to be a very special edition of On.NET. So welcome everyone. This is On.NET, a weekly show where we talk about .NET with our guests and the .NET team. So today is a little special because it's the first time we're recording in the new studios that Channel 9 is very kindly letting us use. So this is a fantastic setup with great microphones, great cameras, great lighting.
Great guests.
Yeah, that too. So we're going to make a few announcements today, and then we'll be talking with Lucas Meijer from Unity. Hi, Lucas.
Hello. Actually, your great new camera is only showing like half of your face. Maybe you want to rotate it a little bit.
Seriously?
Yeah.
Because it's using...
Oh, yeah. That's what you're seeing, but our audience is seeing.
All right, I can deal with it. I can do it.
It's not just me. We also have JB with us today.
Hi, everyone. I'm JB, and I'm the dev lead for the tools for Unity in Visual Studio.
Excellent. Okay, so we have a few announcements. First, some announcements about .NET. So we have published a blog post, and you'll see me struggle with the controls here because it's the first time I'm using them. And okay, so I want to show this blog post here. We're changing the way .NET Framework is going to be serviced. So we have a blog post on the .NET blog that you can check out and get all the details on that. The general idea being that we are going to have monthly roll-ups of fixes for all the versions of .NET, and you're going to be able to update all the .NET that you have installed on your machine in just one operation. So check out that blog post. Hopefully this is going to be helpful for a lot of people who have to service their .NET installations. The second announcement is kind of a very big deal. Today, the PowerShell team announced that PowerShell is now open source, and it's available on Linux and also OS X. So
you mean macOS?
Yeah, which one is it nowadays?
I think it's macOS.
Yeah, I'm old-fashioned.
Well, macOS is even more old-fashioned, right?
I'm so confused. All right, so yeah, that's that. And apparently, people like that announcement because it's #1 on Hacker News, which is always nice to see.
Which is sweet.
Yeah, I need to think about switching the view now.
Yes.
All right, so that's it for announcements. Let's switch back to Skype here and Lucas. So we've already made one of the first on .NET shows about Unity, but this is the first one that we're having with Luca. So why don't you tell us a little bit about yourself, what you do at Unity, and what we're going to talk about today?
Yeah, so I used to make games. I like to say that this is sort of like my real first job because I always was a freelance game developer, and I started working with Unity, I don't know, like 8 years ago when it was just a few people, and yeah, I guess over the years I worked on many different things. I started off doing a lot of work on the actual .NET integration with Mono. I tend to, for some reason, I keep on ending up being the guy that works on the build system at Unity. Back in the day, I did the me and actually JB helped out a little bit on that, and some other people did. We worked on the Flash exporter team. That's a funny project because I think it's one of the first one, at least that I know of, that that basically ported .NET to like a very exotic platform, being like ActionScript. So because Unity projects use .NET and C# code for game developers to make their games in, because we wanted to allow you to export a program to Flash, we basically had to convert all our C++ code and all of our customer C# code into ActionScript, which was a, let's call it an interesting adventure.
So does that have anything to do with what you're also doing? I mean, did you reuse some of that code when you did the IL to GL? Yeah.
IL to CPP. So yeah. So
Not
after,
really, right?
well, no,
Because you're going through C++, aren't you?
So when we did the Flash exporter, we converted like actually the way it worked is like we used the mono C# compiler to compile the C# into an assembly, and then we used Cecil, which is an open source library that JB wrote, to read that CIL code, and then we used nrefactory to reconstruct C# AST from that. And then we basically we bashed and molded that C# AST over and over and over until it contained no more language features that ActionScript didn't support. And then we just printed it out as ActionScript. It's we didn't use any code from that adventure for our later IL to CPP converter, but we did use a lot of our knowledge of like the kind of stuff that works and the kind of stuff that doesn't work. So maybe for people that don't know, like, so after we did the Flash exporter, I worked also for a while on the team that did our IL CPP runtime, and that is, it's a program that takes in .NET code as input and it generates C++ code as output. And the reason that we built it and that we like it is that that the C++ code is very portable, and because Unity needs to target so many different platforms, we were really looking for like a portable solution. So with the knowledge of how to do C# converters in general, we tackled the C++ one. But we picked a completely different design, a much like the Flash one. It was a converter that was like AST based. So we really like the benefit of converting it on an AST level is that the resulting code kind of looks like the original code. But there's also like a million different kinds of ASTs that you can find in the wild. Whereas with still the amount of operators you have and just possible combinations, like it turned out to be a much smaller problem space. So on IL CPP we actually convert the IL code directly. So the generated C++ code, it doesn't actually look so much like your original C#. It looks like what you see in ILSpy. Which is
in what?
In ILSpy. It's like just the IL code.
Oh,
if you
ILSpy. Oh, sorry.
So yeah, that's a bit sad in terms of one-to-one readability of the code, but it is very good for if you care about maintaining the exact same behavior. So yeah, so I worked on that for quite some time.
Before diving into the technicals, you mentioned that Unity supports a whole and a large range of platforms. Could you expand a little bit on that and the different platforms you support and their and the challenges to support them?
Yeah, so I mean, I guess if I take a step back, like the reason Unity exists is that I wasn't there from the start, but when they started, making games was kind of a pain in the ass, and there were no good tools to do it. And we set as a goal to make it easier to make games. And one of the big problems that people had was that if you had to port to a new platform, it basically meant that often you had to rewrite a lot of your code, if not all. And one of Unity's strengths is that it tries to make that process be as easy as possible, which basically means that we take the pain instead of you. So the way you make a game in Unity is like you develop it in the Unity tool, and then you can export to Windows standalone, Mac standalone, iOS, Android, Windows Phone, or how? You're joking about macOS, but what's the Windows platform name du jour? Like
UWP.
WebGL is actually an interesting one. But basic and the way we, of course, like we cannot make porting a game like zero effort, because there, a phone uses touch and an Xbox uses a different kind of controller. That kind of problem we cannot make. We cannot make that go away, and we also cannot change the fact that a phone is just less powerful than a desktop machine. But the parts that we can help with, like making sure that we talk to have implementations for all the different graphics APIs and for the audio and for the loading, and that we tweak the loading for for all these different hardware platforms. That is something that that using Unity sort of gets you for free. And I guess that I haven't even started with like the drama that is like Android graphics device blacklisting. There's so many Android devices, and it turns out, on that specific one with that specific driver, if you ask for a render texture that's not square but bigger, the kind of rules that you see in our graphics code that sort of like work around issues like that, it's insane, and it's also completely unreasonable to ask from a game developer to take on to go and do all that research and analytics to figure out exactly which Android drivers crash on what. It's not only Android, but
it brings back memories of MS-DOS games.
I mean it very literally when I say that sort of like we take the pain so you don't. Like if you look at our testing farm of like all the different Androids we have, but not only Android. I mean, it's also iOS. And it's not only it's not that these are horrible platforms. It's just that there's so many platforms and they change all the time. Like if you sneeze and there's a new iOS SDK and they change the rules a little bit and they remove this thing that you need, or it turns out that I don't know, the new iOS driver, if you do this thing, you fall off a performance cliff. All that sort of stuff. We need to keep an eye on it all the time and make sure that the Unity runtime works well on it. And it's just not the kind of stuff. It's not the kind of stuff that you're really looking forward when you make a game that's fun.
Yeah,
let's put it like that.
We can't really expect users to deal with that, and it's the same problem with mobile, and to an extent, it's the same problem with the web and so on. So
there's a lot of. I mean, this multi-platform thing. It's a big thing because we take care. We don't take care of all of the platform. All of sort of the work that comes from supporting a platform, but we take care of a lot of it, and not only maintaining a platform, but also being able to sort of like switch relatively late in your development process, because a game can easily take 2 years to make, and it can very easily be that if you start now, that the platform that you end up wanting to target 2 years from now doesn't exist yet today.
Yeah.
And you don't it sucks to be in a position that you're almost done with your game, but it's not written for a platform that you would like to support. So having some trust that you're building on top of a tool that typically supports all the relevant platforms gives some give some trust that you'll be able to export to ship your game on such a platform, at a reasonable cost in terms of time investment in order to do the port. So that's sort of like that is sort of like why we started to make it, and why many people choose to use it. If like to answer JB's question about technically interesting things that come from those platforms, I guess Flash was the most Frankenstein one we've ever done. One that comes close is the exporter to WebGL. We call it WebGL, but technically it's kind of JavaScript. So Unity used to have a exporter for the web player, which was a browser plugin that we provided that was able to play Unity content. But Firefox and Chrome, they disabled browsers. They didn't disable browsers. They disabled browser plugins. So now what we need to do is we need to convert all our C++ code to JavaScript. And then we need to convert all the customer C# code into JavaScript, and then get the whole, then get the whole thing running in the browser like that. I would say that probably today is the sort of like the weirdest platform of the bunch.
So you do use Emscripten and stuff like that to do the C++ to JavaScript?
Yes, today we use Emscripten to do the C++ to JavaScript conversion, or the ASM.js, which is kind of like a subset of JavaScript that the browser guys are able to make fast. And that actually works quite well. And that actually also shows why, like, one of the reasons why we like the IL2CPP runtime is because typically targeting JavaScript would be hard with the .NET runtime. I'm not sure actually. Is there actually another .NET runtime that's able to run in the browser on JavaScript?
I'm sorry, what?
Maybe actually ILCPP is the only one these days that can target JavaScript in the browser. I'm not actually sure if there's
I don't know. I kind of recall that there are some other projects, open source projects, aiming at the same kind of thing, but to my knowledge, it's definitely the most advanced and reliable.
So, I mean, it shows like ILCPP really shines there, because even when we have to target a difficult platform like JavaScript, because we already have the requirements that we need to get our own C++ code to run on the platform, if we can convert the C# code to C++ too, that puts us in a pretty good spot, because it reduces our problem to getting C++ code to run on a platform. And there's not many platforms left that ship without a C++ compiler. Actually, Frank, who you had on your show last week, he didn't build like a full JavaScript VM, but he wrote a AST-based converter 1 or 2 years back. I'm not sure what happened with that actually. He took the AST-based approach, which worked better for him because he kind of wanted nice-looking JavaScript, and he didn't care so much about 100% identity behavior. He was fine to adjust the C# a little bit to get it to match. But yeah, that's sort of the WebGL story. It's a little bit of a sad story actually, in some sense that, like this year and the year before, there's this gap of 2-3 years where what you can do with games on the web is actually less than you could do last year. With the browser plugin, there was more stuff that you could do at a better performance. the WebGL stuff is really getting there, and the browser people are doing really good work at filling all the gaps. But if you were 100% web game developer, you had a pretty rocky last 3 years.
So it's going to be one step backwards and 2 steps forward, hopefully.
Well, I hope that we're done with the steps backwards by now. And it's a matter of how many steps forwards we take. I mean, there's still a bunch of features missing from the browser JavaScript platform that games would need, like the multi-threading with access to the same memory. What is it, like I forget, like that's the biggest one. SIMD is something that gets used a lot by game engines for stuff like skinning. So there's still some gaps. But it's closing pretty fast.
So we're working on SIMD for ASM.js, right?
Yeah. So the good news is that the browser people, they really know which parts are missing, and they're doing good work in making. Doing the whole standards body, standardization, prototype, implementation, the whole dance. But because these browsers, they update so quickly these days, I've actually been very surprised at how fast this whole ecosystem goes from a proposal to a plan to a prototype to multiple browsers implementing a prototype to a standard to suddenly it actually works on most people's browsers.
Are you working with browser vendors to make sure that they're implementing what's needed for you and the gaming scenario as a whole?
Yes, we started the WebGL exporter sort of hand in hand with the Firefox folks. So we know those really well, but we have very good relationships with Chrome and Safari and Edge. Because it's funny because we don't even have to do that much about it. Like as soon as one of them shows up as #1 in a benchmark, like there's nothing that will get a browser vendor running faster than when the other guy is faster in the benchmark. So it's been amazing to see how that competition sort of like drives the development, mostly of performance, because the biggest gap was performance for us. So yeah, we've been very happy with the results across all browsers.
All right. I want to tell our viewers, our audience, that they can actually ask questions. So the process has changed a little bit because we are not on YouTube anymore live. So you can go to the Gitter room for .NET. So it's the URL is
gitter.im/.net/home.
.NET/home. gitter.im/.net/home, and I don't know, user hashtags such as onNet, for example. Let's say.
Yeah. All right.
All right, so if you want to ask questions, that's the way to do it, and we're going to do that every week until we find something better. Hopefully we don't pollute the chat room too much.
No, it's pretty quiet.
Okay. Do you have a demo or something to show, some announcements, some news about Unity?
Well, so I don't have, you sent me this big scary email that I should make sure to not accidentally announce something.
It's kind of,
announcements
you have
planned.
to say that.
Although I can talk a bit about, our plans, what we're gonna do with .NET going forward, what our upgrade story looks like. But maybe before we do that, maybe I can, if we can get the screen sharing thing to work, maybe I can
maybe
take
give an overview of Unity, how it works to write a few lines of code for Unity, because it's actually C# and .NET, and we're on .NET.
Yes.
And expand on the .NET story for Unity. That would be great.
Okay, so let me try this.
All right.
I'm actually using my development build, so for
Might be dragons.
So this is what the app looks like. I hope it's not too dark. Um, and actually, it's like I like showing the way that .NET and C# integrates with Unity, because I always have the feeling that a lot of people from the C# world, they really don't understand this Unity thing, and vice versa. People from gaming world and from the Unity world not really, not being that aware of everything going on in the C# ecosystem. So I guess the biggest difference between a typical C# app and Unity is that in a typical C# application, you're used to sort of like being in charge and being, you have a static void main, and from that, you have you have your app, and you can add references, and then those libraries, they expose types, and you can use them, but they're all sort of, there's, like you're sort of like in the driver's seat. And you're still in the driver's seat at Unity, but in a different way. And I think the way people often incorrectly view Unity is sort of like as a C# library that makes it easy to use C# to do game stuff. But it's the way I look at it more is that Unity is like a game development tool that has a player, and all of that C++, or like C++ and assembly, and I'm having a hard time finding my words. Let's just dive in and show it. So this is let me mute the audio. So this is a sort of learning game that we have. You can walk around and shoot some baddies. You can hit pause. So I can hit pause in the game. You can play the game while you're in the development tool. You can pause it and you can like look around the scene here. And Unity itself, it has a very sort of like, I guess you could even say like, simple architecture. Notice I have the hierarchy here. All these things are what we call game objects. And the only thing a game object is a collection of components, which you see over here. So for instance, this game object point light, it has a transform component and a light component. And if I turn off the lights, the light goes off. And each component has a bunch of exposed properties and settings that I have.
Can you full screen?
Can I go full screen? Yes. Or let's try that. I hope I don't crash, because when I was doing this before the call, it was crashing all the time. Okay, so I can select some different game objects, and we can take a look at what kind of components we have. So this is a mesh renderer component. It's responsible for drawing the actual object. And then this one also has a box collider. And the collider is a component that lets this game object participate in the physics simulation. Let's see if we can select this thing over here. There's a fire truck. You can open this up. These game objects, they can be children of each other. And this fire truck is actually made of a few different ones. You can see that the people that made this try to actually be relatively accurate with the collision shapes on this thing. So we have
what we can see around the wireframe, the green wireframe that we can see around is the collision boxes.
Yes, those are the collision boxes. Exactly. So each of these components, they can have different visualizers in the scene view. So, like the mesh renderer, it uses this wireframe visualizer in the scene view, and the box collider uses the box, and you can use them. You can also, do we do that right? Oh, it's because it's static. Now you can make it bigger, smaller, and do all these things. So there's a genre of physics-related components like a collider or a rigid body, and then there's mesh renderers, lights, cameras. All these things are implemented as components. And the way that .NET fits into this model is that you can make, actually pretty much the only way .NET fits into a Unity project is that you can make your own components using C#. So let me show you how that works. Let's grab this chair here. And I already wrote this rotate me script. So I'm going to drag this on. You can just drag one of these scripts onto your game object and it becomes a component. And let's edit that thing. So here.
Could you increase the size of the font just a bit?
Resize the font. Oh, what do you know? Oh.
All right.
Okay, so I can do get components transform that rotate 1 to 3 in update. So update gets called every frame, and what this does is on the game object that this specific component is on, I'm asking for a reference to the transform component on that same game object. I don't do any checking because the transform component's pretty much always there, and then I call rotate 1 to 3 on it. So I've been doing all this in play mode. So if I unpause here, look at that.
Nice.
So you can do.
Can you add more than one of those behaviors on the same object?
I can. Let's do that. Let's drag one more on, and it will go twice as fast.
Right.
There's a few more things you can do with this. For instance, you could use public float speed, and then I could do this, and then all the public fields of a component, of a C# component, are actually exposed in the UI here. So now they don't do anything. I can put that one to 5.
I like the music.
So, so just as all of the components that are built into Unity, in our C++ code are exposed as components, your own behavior, you write them as components as well, which is a little bit like well, I get into that a bit later. Let's see, there's a few more things you could do. I could, for instance, do, let's see, I didn't practice any of this. Audio clip, let's see, my audio clip. If you do that, you can see that you can not only expose things like floats and ints, but you can also expose references to other objects, and those objects could either be assets or other components. For instance, one of the things, actually maybe we should do this. Maybe we should do public transform my target, and then we do if my target is null, return. And then instead of trying to rotate the transform of the component we're on, we're gonna rotate this transform that we expose through the UI. Let's try that. So now I need to find something that we could rotate.
One of the little dude.
So I think you went a little too fast here. Can
Little
you
too
switch
fast?
back to the... Okay, so what's happening here? So you have a new public property that's a transform.
Yes, so transform is a type from Unity. It refers to the transform component that exists on each game object. And the transform component describes where this game object is in the world. So you use it to change or read the position of an object.
So we are going to be able to pick an object here and just apply this transformation.
Yes. I do a safety check here, because if I forget to assign the component I don't want, it give me a null ref. And then assuming I have it assigned, I'm actually going to rotate it. So let's try that here. I can actually select, let me try, let's take the fire truck. I'm going to select the fire truck and drag it onto my target here. And I'm going to unpause. No. Oh, did it delete all my things? It deleted all my things because I was game over. Okay, so let's add the rotate me and grab the fire truck. Where is the fire truck? Here's the fire truck. Put that in and give it a speed. Here we are. So now it's the fire truck rotating. And in a nutshell, this is kind of how all the scripting in Unity works. You let Unity do the heavy lifting of the rendering and the physics simulation, and most of the things you do is you change things on components. Yeah, that's sort of what it boils down to. You change things on components.
So you script the world basically. You add behavior to the world, and then
yes.
The world goes on its happy path and updates automatically.
Of course, I mean yes, I guess yes would be a reasonable answer to that.
How, for example, how do you handle events going on in that world? How do you handle a collision, for example?
You would write something like void on collision enter, destroy my target. Actually, this is one of the API mistakes we made 8 years ago. So when we integrated .NET 8 years ago, or like right before I joined, we had no idea what we were doing. When I was talking before about how the C# ecosystem is kind of foreign to many game developers and vice versa, that was definitely true for us. So we just figured that this was a good way to do it, which is sad because it's not a virtual. So if one of the problems that beginners often run into is that they'll have a typo in here and then it doesn't work.
So they're not discoverable.
Yeah, so they're very undiscoverable.
If you allow me, that something that if you use the proper IDE with a proper plugin, that would be fixed for you.
That would be amazing if someone were to make that, yes.
So using the tools for Unity that Unity installed for you, if you're running on Windows, you get wizards to create those mono-behavior functions without typo for you.
Yes, that's very nice of JB to sort of clean up after our API design mistakes. The good news is that back then we also picked a bit of an awkward name for the base class of these components, like a mono behavior, which is a bit awkward because in some way mono is more like an implementation detail. It would be better to call it either a script behavior or maybe a .NET behavior. So it means that sort of the nicest name for the base class is still available. And one of the things we have on our, I wouldn't say roadmap because it's not very near in the future, but on our list of things that we would love to do is actually make a new version of this mono behavior base class that fixes all these sort of API mistakes that we made. Because there's a few more of these. One thing that since I wanted to touch upon sort of what the difference is from traditional C# dev to C# dev in Unity is that it's not it's Unity who is actually constructing these objects. So one problem that you have in game development is you're running through a level, and you're getting close to a door and you want to already start loading the next level. Unity can do that for you, and what it needs to do is it needs to load all these objects from the hierarchy and all these components and all the things that they reference. We need to make sure that that's all in memory and hooked up and ready to go for when you go through the door. So that means that Unity is in control of when components get created and destroyed. And it's also Unity who's responsible for setting these public fields. And this is something that is a very foreign concept for most C# developers. At least it was for me when I started. It felt very, it took me a long time to sort of like let go of my desire for being in control there. Because you'll notice that this component, it doesn't have a constructor. And we strongly recommend not to use constructors for these component types. It's fine to use constructors on everything else, but if you derive from mono behavior to make a component, which is what you a lot of the time are doing, we recommend against using constructors because you don't actually are in control of when they get called. And you're not in control of when these properties get set. So the initialization work, like the stuff that you would want to do in a constructor, you would either do it on start or on awake. I won't go into the difference of that for now. And like if you want to create another component, instead of doing instead of doing like this dot my components dot add new rotate me, this would this style would be sort of like traditional C# style to create an object. What you do is that you call add component rotate me, and then Unity is responsible for actually instantiating it and getting it set up. And in a way, it actually, like, Unity in some ways can actually get a little bit close to what some people try to do with like dependency injection, which is also sort of a technique where you kind of give up exact control over your object construction, which you don't give it up completely, but you let someone else do it, and either set up your fields or call your constructor with certain context variables. Is that if you want, I'm having a hard time explaining what I mean. I guess what I'm trying to say is that there's sort of a parallel between Unity setting these fields up for you and what some people do with some DI frameworks.
Yeah, it looks like property injection more than the usual constructor injection, but it does look a lot like dependency injection, yes.
And I guess one of the differences is that like the setup of a lot of your object graph actually comes from a data file that Unity makes. And you set up at least your component object graph, you set it up using this UI. Where did we have that on the like if I want this object to reference this thing, or maybe I want it to play a certain sound when something hits it, then I would add like an audio clip field here, and it would select the audio clip from a project and attach it to it. And by letting Unity do that, you also get all the benefits that Unity knows statically which assets that this component is going to need. So that means that we have a lot to go on when we do all our level loading code, that we know statically all of the assets that will be required by the scene, so we can already start loading them in the background and do all sorts of prefetching on them. Yeah, so that's a big difference. That's I think probably like the biggest difference between traditional C# development and C# development in Unity is that you sort of like have to start getting understand the sort of like the place that C# and .NET has as part of the bigger picture.
So you mentioned, Lucas, you mentioned an effort to maybe make the Unity API a bit more native to .NET. So it's clear in terms of mono behaviors and the messages, the functions. But what about those fields? Would they become properties in your mind?
So that is.
I think that if they were simple properties, it would make a lot of sense for .NET developers.
So it's a very common request for us to support this.
Because
what is
object-oriented programmers have been taught since school that they should not make fields public.
Yes, so I'm not a big fan of dogma like that. If you, for instance, one thing that we do support is like it doesn't have to be a public field. If you want to make it private, that's cool too. But you will have to add the serialize. What is it? Serialized field. So I'm not saying that we will never do it, but the concern we have with this is that that people will actually write code in here. They'll write some they'll write some validation on the value.
Yeah, they should be allowed to. That makes sense.
Yes, except should they be allowed to? So one of the problems is that because we load these components on a separate thread, you get these calls, like we set these things at times that might not be immediately obvious to the developer. And also on threads that are not the main thread, whereas a lot of the Unity API is only available on the main thread.
And in a lot of ways, is it accurate to say that game development is not like regular development, and there are a lot of constraints that you don't get otherwise in terms of perf and.
No, that's a bit too. I think that's a bit too generic. But one of the big things that you get from Unity, which is like the loading mechanism. That loading mechanism, it comes with a lot of upsides, but it also comes with some constraints. And this is one of the constraints, at least today. We've been thinking about supporting this somehow. We just need to find a way, because people will do stuff like this, and then there'll be like a void validate, and then in here they want to call, they'll end up calling like some Unity API, that turns out to not be thread safe.
So you're getting a lot of uncertainty in behavior that you don't have today because they are just simple fields. So you know exactly what happens, and that introduce a lot of complications, and probably some stuff would start breaking down in creative ways.
And also, like the process of when we load a scene. We deserialize all components, and not only the C# ones, but also the native ones. And we have incredible performance requirements on the serializer. One of the nice things about fields is that we are guaranteed that no code will run as part of that. Again, I'm not I completely understand the request, and I feel that it's there are some use cases that are very hard to do without any property support. So it's something that we need to, these are use cases that we need to support, and whether it's going to be through full property support or through some, some variant is something that we still need to decide.
Okay.
And I mean, there's some other things like there's a lot of these messages here. There's also things like, on enable, on disable, and we're not always incredibly accurate with making sure that for each on enable, you always get on disable. And basically cleaning up our entire sort of like object lifecycle and which callbacks you get when. That's something that we would love to do, and that is also very hard to do without changing the base class. Because if we change which callbacks you get when, everyone's stuff will break. Because everyone, figured out how Unity does it today, made their code work with that, and if we're suddenly gonna send the extra on disable call or remove one, everyone's code will break. And if there's one thing that we are incredibly passionate about, passionate yet not perfect, is that we are not, we will go through enormous lengths to make sure to not break user projects. That's like one of the biggest things for us is that if you have a Unity project, Unity 5.0 project, and you open it in Unity 5.4, it should be a minimal amount of work to get it working. And it's not always possible to do that, but definitely not going to introduce change.
Okay, so I have to apologize here. This is super lame, and I feel really, really bad about this. So what's happening here is that I didn't bring my power supply, which is really, really lame. So just give us a couple of seconds. JB, who has apparently a larger battery than mine, is just going to call Lucas back, and we're going to resume the call. So sorry about that again. That's super, super, super lame. But
it happens.
It does happen, and it will only take a second, and we'll be back. What kind of, okay. HDMI, there you go. Okay, so, trying to call Lucas back. And we'll have to share screen again, but we should be fine in a couple of seconds. There you go. All right. Are you still there? I'm sorry about that. Can you hear us? Okay. Excellent. So we're back, and if you can share your screen again, we lost the last minute or so. I don't know when you.
Can you hear him?
Actually, no. I can only hear him very, very, very weakly. So yeah, you probably need to switch the audio to
Speakers.
Let's try. No, not that one. No.
That's about all I have for the audio.
That's the only options you have. Okay. So while we're trying to reconnect, I'm going to try to make you multitask a little bit. What about the Visual Studio extensions for Unity? What are they doing that is, when would you use Visual Studio?
I cannot do this, man.
You cannot multitask like this. That's too hard. Yeah.
All right, so you can try to figure out the machine.
Okay.
And I'll go ahead and talk about Visual Studio and the integration with Unity. Sorry, Lucas. So since Unity 5.2 on Windows, Unity will co-install the Visual Studio Community Edition for you, Visual Studio 2015. And as part of it, we'll install this Visual Studio Tools for Unity plugin. And what this set of tools, this Visual Studio extension is doing is that it allows you, it works out of the box with Unity on Windows. So just like Lucas showed you here with MonoDevelop on OS X or Mac OS, on Windows, you just have to select Visual Studio to be your script editor, and everything will work out of the box. You can write your components in C# in Visual Studio for your Unity game. You can debug your game. You just press F5 and Visual Studio will attach its debugger to the Unity editor, where we can debug all your components. And you also get a set of productivity features that are specific to Unity developers, basically touching the same problems that Lucas did. It's hard currently to discover the functions that you need to write inside those mono behaviors when you're writing a game, and Visual Studio Tools for Unity provides you wizards to create those functions for you, so you're always sure that you're not mistyping them. And in the future, we'll be working to integrate them natively inside Visual Studio IntelliSense, so it's even easier for you to discover them. Pretty much just like you would override a method, and Visual Studio gives you the list of methods that you can override. We'll give you a list in the IntelliSense of the monobehavior functions that you can implement.
Okay, thanks.
Sure.
So Lucas, how about we try again? Can you say something?
Hello, hello, hello.
Yeah, that
perfect.
works. Excellent. We'll get better at this.
Yeah, I mean,
Next week will be better. The week after that will be even better. All right, and next time I will bring the power supply and everything I need. It will be awesome. All right, so let's just switch back to the demo.
all right, Lucas, up to you.
Yes. Can you see my screen?
Yes, we
Yes.
can see your screen.
Where did you stop hearing me talk? Attention.
It's hard to say with all the panic and the frantic trying to find the power supply.
But yeah, we were like we ended up discussing like the differences in terms of approach.
Oh right, yeah, I guess we were talking about this property thing.
Properties, yeah.
So probably we'll find a way to do the property thing somehow, or at least give you a reasonable use case on how to do validation. And yeah, like the cleaning up of like the object lifetime cycle, like which events you get when. That's something that we really want to clean up. And it's something, but the problem is that we only sort of like get one shot to do it, because we have to create a new base class for it, and we cannot go around, making like script behavior 2, 3, 4, 5, 6 on every release where we feel like we could make the API a tiny bit nicer. So we're gonna take our time to make a replacement for mono behavior. The old one will still exist, but add another one that sort of like contains a decade of our learnings of things that worked well and things that didn't work so well. And yeah, I'm really looking forward to ship that, but it's gonna take a long time, because before we start really digging into that, we first want to get our .NET update story in a good shape.
So
that means
before discussing the .NET update, what's the current state of .NET and C# inside Unity?
So the current state is that we use limited to the C# version. I think it's called 3.5, or framework 3.5.
Okay.
So you have things like properties, lambdas, all that stuff, but you don't have async await, and you don't have like the newer C# 6 stuff like expression bodies and string interpolation. that stuff is still at the other side of the fence.
Okay.
It sounds like async await could be very beneficial.
Yes. So there is a
Actually, maybe that's the perfect opportunity for you to show.
yeah. So we have our own we have our own version of async await, which no, that's that's pushing it. But one of the patterns that you often have in game development is that you want to do something, and then you want to wait for something, and then you want something to happen again, and then you want to wait for something. So like you could want to write something like Prince.walk to castle, and you would actually want to wait for this. So the way we have this is that you could do I-enumerator. We basically implemented it through the yield return mechanism.
Interesting.
And you can do yield return wait for seconds too. And then here you could do castle.bridge.open. And maybe you can yield return that too.
Yeah,
but it's not as powerful. Like it's nice. It's very helpful. It's very helpful, but it's not as powerful as async await.
Actually, I've seen people use similar patterns in JavaScript, where enumerators like that appeared recently, and it's interesting that the same patterns seem to appear to simulate some language features that are still missing.
Yeah, and it works okay, but it's not as complete as async await.
Yeah.
When we designed the Unity API, async await didn't exist, and right now right now the mono that we use doesn't have async await either. So it didn't make much sense for us to go and think of how we would redesign the API to sort of work nicely with async await. But that is also one of the things that's on
your radar.
That's on the radar. That once we get our .NET upgrade story in a good shape, together with the script behavior, we should take a look at what kind of API changes we would have to make to make writing code with async await be a pleasurable experience.
This is actually something that you should talk with the C# team. They're developing those value tasks.
Yes, that is super interesting work. Yeah. Because one of the concerns we have is always managed allocations, and the async await stuff is it still allocates quite a bit, but there's been some very nice work recently on the value task stuff. So yeah, we're looking at that with how do you say it? With open arms.
So you were talking about language features. What about the class library and the framework itself? Are you still using an older build of Mono, or did you already upgrade to more recent ones?
No, so we are so today we use a relatively older version of Mono, so the .NET Framework 3.5, which pretty much all of it you can just use from your C# code. One of the reasons that we haven't upgraded to a new Mono yet is that it's an incredibly invasive change. I mentioned before that we care a lot about not breaking user projects. We oftentimes, we do. Sometimes there's no way around it. Sometimes you make a decision that something is so valuable that if some people have to do some work on the project to upgrade it, maybe that's okay. But it's something that we keep in mind a lot. So of course, changing the .NET runtime is an enormous thing that's going to affect everyone. So the way we're going to roll it out is that most likely in Unity 5.5, we're going to upgrade the C# compiler, but we most likely will not turn on the new language features yet, which is a little bit of a dead bird gift. Because some of the new language features, they require new base class libraries. For instance, async await requires all the task types in the BCL, and it would at least be a very complicated message to say like, yeah, well, you get a new C#, but not all the async await stuff you wanted.
Yep.
And there's also some concerns about tooling support in the Unity ecosystem. For instance, we have a script upgrader that is able to, when we make API changes in Unity, we have a separate tool that's able to scan your C# code, see if you use that API, and if you use it, apply a refactoring to your code to use the new one. It's incredibly useful because it lets us do much more API changes than we would otherwise be willing to do. But there's sort of we need to make sure that tool is able to understand all the new C# features as well. So we probably will not turn it on yet, and then the next big step will be upgrading the mono runtime and the class libraries and the C# compiler, most likely in one go. And we'll start doing that through experimental builds. So it's not going to be that long away in the future that we'll have experimental builds for people to try. And then when we get enough confidence that the upgrade story is looking healthy, then we're going to roll it out, and then there will be much rejoicing. Actually, this whole upgrade story is also the reason that we are incredibly happy with the new direction of the CoreFX folks. Like when the CoreFX thing started, there were a lot of API changes in the profile that I'm sure were made with good intention, but they would have broken our customers' projects. There was things like .get type was removed, or like the thing you get when you do .get type now had way fewer methods on it. Mm-hmm. Like that, a change like that is just for us, it's just completely unacceptable. Mm-hmm. Like there would have been no way that we would have been able to adopt CoreFX or any new kind of .NET direction if it meant that we had to tell all our customers to rewrite all their code because we decided that in a new version of Unity we're gonna change C# and now it's completely different.
Yeah,
and
that makes sense.
That's also a point where C# is a little bit different than Unity. Like upgrading your C# language is a very conscious choice that you make, right? At some point you decide, okay, maybe I want to make the switch to CoreFX, and then I'd be willing to put into work to get the benefits that provides. But because in Unity it's all in one big thing, it's very likely that someone who upgrades to Unity 6, they're not interested in the new C#. They want to have the new light mapper.
Right.
But now suddenly, because they want to have the new light mapper, like all of their scripts, probably, that they themselves only wrote 5% of them. All of them are Spoon compilers, and no one has an idea on how to fix it. So we care a lot about project backwards compatibility, and we're very happy to see this new direction where the CoreFX profile will not be smaller than the .NET Framework one. At least when at least when we're talking about the MS Core lib and the system core parts of the profile.
That makes a lot of
The more
sense.
obscure assemblies we don't, the more obscure assemblies we don't care about so much.
Okay.
Shall I stop sharing my screen? I think this code has lost most of its.
Yeah.
Just
Probably.
Here we go.
Yeah, it's been a little static in terms of video.
Yeah, so that's kind of the .NET upgrade story. We're very enthusiastic about it. We can't wait. We've been on a pretty old .NET for quite some time, and we can't wait to allow our customers to use all these new features. We're going to keep the ILT CPP runtime. As I said, like its portability is really helping us out a lot. Now that Mono is also MIT licensed and Core CLR is MIT licensed, it's likely that we'll look at sharing or recycling some, more code with the other .NET runtimes. You could really wonder if you need 3 different implementations of, like a metadata reader. But at least the code generation part, which is the part that we care most about, that we're very happy with, and that's not going anywhere.
What about the garbage collector?
The garbage collector. So the garbage collector is probably the piece that will come after the .NET runtime and the base class libraries.
Okay.
Like we very much see the need of shipping a new garbage collector. It's just a lot of work, mostly because the smarter and the better your garbage collector becomes, the more requirements it puts on the code that uses it. So for instance, like the Core CLR garbage collector or the Mono SGen one, they need to be informed whenever you write to manage memory. And that is actually something that we do a lot in Unity. So we need to, actually, of the last year, I probably spent 4 months changing Unity code, like changing the way we interact with the VM to make sure that all the times that we write to manage memory from C++, that we can find those using compiler errors, so that we can add write barriers to all of them.
Nice.
Yeah, it's like mostly it's mostly write barriers that are the most blocking thing, at least to upgrade to SGen, like the Mono's garbage collector. We actually don't know yet which one we would like to switch to. I know that Miguel has been very impressed by the Core CLR garbage collector as well. We've talked to the GC team at Microsoft a while ago a little bit. Like they're very friendly and willing to sort of like try to get their GC to work well with Unity, but as I said, like the more complicated and the smarter and the better the GC, the more it needs to tie in with whatever program it does the GC for. So it's not super trivial to just take the GC out of Core CLR and put it into Unity or into Mono. So yeah, it's something that would come after the Mono upgrade and the compiler and the base class libraries. But it's something that we that we see as, that we recognize that's a pain point and that's something that we need to fix.
All right.
And I can't wait to actually get that. Like, I can't wait to get us on the new C# and the new BCL and like a modern garbage collector. That would be when we find that would be a good day.
Do you actually have plans after that to keep up releasing like newer versions of Mono or .NET, whatever you end up using, to avoid like a large gap like you had?
The desire, yes. but it really depends what these upstream projects decide to do. For instance, like if what I just mentioned about core effects that went into a direction where they were removing APIs, like if an upstream project's doing that, then no. So it really depends on how much work it is to integrate a new version, and that goes hand in hand with how backwards compatibility breaking the upstream changes are. That said, you know, the design, like I know, like now that we're working on the mono runtime upgrade, even in the process of upgrading it, I think they take upstream mono changes, I don't know, every week or every 2 weeks, 2 weeks or something. So the rate of updates can be a lot, you know, they can be faster. On the flip side of that, every upgrade you do, you know, comes with engineering effort and testing effort and risk. So it really depends. Like, we're not going to do the work to upgrade to something new if there's not something attractive in there. But if there's a new feature that we really want, you know, then it makes sense to put the work in. So it really depends on what the upstream project's doing. But for instance, on the C# language front, like in C#7, the Roslyn team added the ref returns, which is something that we want incredibly badly. So like the ref returns will allow us to have much faster APIs, C# APIs that need to access C++ data, because like in our API we have that a lot, right? Because most of the data, like textures and vertices and meshes and sounds, all the data is in C++, but you want to expose it to C#, but you don't want to have all this expensive marshalling going around. So the ref returns will allow us to make that a lot more efficient. So as soon as C#7 ships, you can bet your bottom boogie that that's going to be one of the first things that's going to get like a round 2 of upgrade.
All right. What about security updates and stuff like that? Do you worry about that? Is that a valid version to get updates to the framework?
It depends. So I guess like our security situation has gotten a lot easier because we no longer distribute a browser plugin. When we distributed a browser plugin, like the Unity web player, you know, obviously a browser plugin comes with all sorts of security concerns. So those are now, you know, it's sad that what's possible on the web with games, you know, has decreased a bit over the last 2 years, but at least what we got back for it is that, you know, we have fewer security problems. They're not completely gone, of course. Like Unity customers use Unity to do lots of different things, and some of them need to be secure. So yes, like we will take them and we will update them, but I guess, you know, it's no like the time pressure to do it is no longer measured in hours.
Okay.
But I mean, like I mean, that's a bit of a too blanket statement. It really depends on the vulnerability. It really depends on the vulnerability.
That makes sense. All right, so this has actually been a pretty long show. So thanks again for being on the show. This has been really, really interesting, and I hope our viewership will be as interested as I was. We did have a few hiccups in the setup, but hopefully this is watchable still. So I want to thank everyone for watching, tuning in today. I want to thank JB for being on the show
Of course.
today.
Thank you for having me.
and of course you, Lucas. So
Thanks for having me.
We'll be happy to have you on the show anytime you have something nice
New
to
stuff
show.
to show.
Yeah. This is, I mean, the everything that's happening around Unity, I think is very exciting, and to see a lot of high-profile games being published is
Maybe just before we conclude, Lucas, to give an idea of people that are listening to the scope of Unity. How many developers do you have these days?
I don't dare to say. Like, what I always have to go to the website.
Last I heard was 1.5 million active developer per month.
Yeah, so I think, so don't pin me down on the numbers, but I'm pretty sure that means that like this month, that amount of users has
used the Unity editor.
No, and it's been an incredible sort of like humbling journey to see that we've gone from, like 1 or 2 crappy games to, to so, like if you go to unity3d.com/made with Unity, like if you just Google for Made with Unity, you can sort of like get a feeling for like the scope and the variety of the content that gets created with it.
Even a couple of weeks ago, there was a Unity game that was showcased in the front news in France.
Well, not just
in France, in the US, and everywhere. But I mean, it's not every day that you have a game that is talked about so much.
Can we say what game we're talking about?
I'm pretty sure Lucas can.
Which one are you talking about?
Yeah, Pokemon Go.
Oh, Pokemon. Yeah, so Pokemon's the Unity title.
Yeah.
And
it's huge.
The list is just endless, and it's heartwarming to see, when we're plugging, when we're fixing, working around Android driver bugs or working on the build system, to see that at least the pain we put in, that users are using it to create such beautiful content across so many platforms. It's like it makes it worth it. And if someone's watching the stream and wants to play around with it, like there's a free version. So go to unity3d.com and download it and get started and use all your C# food skills to
build a nice game.
To make something cool.
Oh yeah.
Excellent. Well, that's a great conclusion. People
is.
can go to the website and get started, and maybe.
And there are great tutorials on unity3.com/learn.
And a great plugin for Visual Studio.
Oh yes, so you can use all your tools that you're used to, along with Unity, and get started. Awesome.
All right. Awesome. So that's a great conclusion. Thanks everyone for tuning in today.
Thanks, Lucas.
And thank you, Lucas. And hopefully next week we'll be back, and we won't have the technical problems we had today. So bye everyone. See you next week.
Thank you. Bye.